GM, GE, GA, everybody. Welcome to what's going to be another great Dev and Tell. If you didn't know, Dev and Tell is a 30-minute window for members of the DAO to showcase something they're passionate about or have been working on. This can be an awesome project you've been working on, demonstrating unit testing best practices, automation goodies, smart contracts, how to structure a project, etc. Basically, if you've got a passion for something, this is your opportunity to share with the community. And today I am happy to introduce to you Matt from the Ceramic Network, who will be going over composable data with us. Take it away, Matt.
Excellent. Thank you for the introduction. Hi, I'm Matthew. I'll share my screen really quick and we will get going. Why is screen sharing always a challenge? You'd think after doing this so much that it'd be easy, but no.
I feel
So
you.
we're going to talk. What's that?
I said I feel you. Yeah, but go on. Yeah.
Yeah, it's so funny. Okay, we're going to talk about ceramic a little bit. I'm not sure if you guys are super familiar with it or not, so hopefully after the end of this, you'll have an understanding of what we're doing over on our side of things and how you can fold it into your app. If I breeze through this quickly, I have a couple demo apps that I can pull up and show you. But outside of that, let's talk about who we are. First and foremost, my name is Matthew. You can find me over on the Ceramic Discord. I'm the developer advocate for our team, and so I kind of run around and hopefully drum up enough excitement to get you guys to adopt what we're doing over here. The rest of our team, however, is way more exciting than I am. We have a crazy group of developers that come from large-scale enterprise Web2 companies. So we have people working on this protocol from Facebook, from Mongo, from GitHub, as well as other financial institutions like Deloitte. They're all there bringing the best minds possible to Web3, which is pretty cool. A couple of key points too is some of the engineers on the team developed Uport, which was the first Web3 identity solution. We've got people that have authored core Web3 standards, such as decentralized identifiers. And outside of those accolades, there's been a ton of developer-centric products that have been shipped and available to use across Web3 applications by our team. So we've definitely been well versed in the old way as well as the new way of doing things, and we couldn't be more excited to looking or to be solving this data problem that exists. So getting into what Ceramic is, easily we could just say, hey, we're a decentralized network for composable data. That's somewhat helpful, somewhat not. I think it's more helpful to break this into two parts. The first part will be composable data, right? So for a decentralized network for it, talk about the data a little bit. The best way to do this is to think about our user journey, especially in the social space. I think this makes a whole lot of sense to a lot of people. Everybody's pretty much living their lives through social media nowadays. Imagine I'm a brand new end user and I land on Twitter. The first thing I need to do is create an account, right? And when I do that, I'm asked to enter my name, my phone number, my birthday. But then I also want an Instagram account because, 140 characters of text just isn't as good as a picture of somebody's really bad plate of food. And I want to see that really bad plate of food, so I sign up to Instagram and I'm asked for my phone number, my name, a username, and password. And then I realized, well, if I'm going to go down this rabbit hole of social media, I might as well be in the most evil of social media companies. And now, so I signed up for Facebook too, right? And it asks for very similar information. And you can see there's a lot of area where we could very easily just reuse old information that is still valid information. Name is a good one, or phone number is a good one. They all ask for it, but as the end user, I've had to put it in three different times. So this is problem number one, is where as a user, I have to do this too often. Problem number two is once I do that, where does it go? The moment I put my information into Twitter's form.
Oh, sorry, gang. If yeah, thank you.
Cool. The moment I put my information into Twitter's form, where does it go? It goes to Twitter's database, right? The moment I do that with Facebook, it goes to Facebook's database. So these pipelines of end user to application are all kind of housed and locked away inside of an application-specific database. So problem number two is it becomes Twitter's proprietary property the moment I give them my data. Then we have to kind of trust Twitter and trust Facebook and trust all these other applications. that when we request a view that uses that data, that we're actually getting the proper view or something that's true and that they're not manipulating it on the way or doing other things with it, right? So there's a lot of trouble with that. There's the developer problem, right? Not just the end user problem, but the developer problem of if I need to integrate with one of these applications, I have to implement some sort of one-off API in order to do so. And if my application starts depending on that API and all of a sudden Twitter says, nope, we're going to cut you off, you're no longer going to have access to the API. Like, what are the business effects on my application the moment I lose the ability to interact with these APIs that somehow get closed down, right? So there's a lot of different problems that are boiling up with the current Web 2 system in data, and it all points to the same thing, and that's the moment you provide your data somewhere, it's no longer yours. You have no agency over it. And we've seen this a lot with how like data is sold and how it's used in for to manipulate all sorts of ad campaigns and stuff, right? It's not yours anymore. Even requesting to delete your data isn't an easy thing, and you then still have to trust that it got deleted. So at Ceramic, we're trying to say, hey, like, how can we solve some of this, if not all of this, all these problems that we just talked about? So we look at this from a composable data point of view. So we can take our little developer here, and maybe that developer creates a schema for what a profile looks like, and we call it a data model currently. And this contains data that a user would enter, right? Their name, their birthday, their phone number, everything we just looked at. And then whatever applications are built aren't reading or logging that in their own database. Rather, they're querying the Ceramic network for that profile data and then filling the page or the sign up forms or whatever it might be with that data as the application then needs it. What we get out of this is the user now has a central place where if they decide to change their name or they change their phone number, they can update that in one central location, which is on the Ceramic network. Not that it's centralized, but just like that's where they would update that. And then that immediately gets reflected across all the Web3 applications they use that read from that data model. And we're not limited to one data model per application. We could pull in 100 different data models per application. And we also keep the APIs open. They're not going to get shut down. It's an entire decentralized network. So this data is also always available. And we store this data in something called streams. So if you're digging into the documentation, you're like, I want to implement a data model. What I keep seeing all this stuff about streams, well, this is kind of what a stream is. We'll talk about it briefly. You can think of a stream as this append-only log of commits, right? And they all get reduced down into a stream type. So it's the history of changes to that data. I've updated my name. I've changed my phone number. I've added a new field that didn't exist before. All of that gets captured and lives alongside of that data interaction in that data model forever, which is kind of cool. And it's append only, right? So we can't remove stuff out of it. We can very definitively say like this is the history of the data. So each one of those commits is actually a content identifier that's an IPLD object, right? So you can start to see now that Ceramic layers on top of IPFS. You need to be running IPFS in order for the Ceramic protocol to kind of interact with that. These stream types aren't just a series of commits like the stream is. They also provide logic for like what can happen with that stream. Currently, we support two different types of stream types. The most common one is a tiled document, and you can think of that as like a MongoDB like document style database, big object of key value pairs, right? Um, there's another one that deals more with like Cape 10 links, and then there's a couple that are in the works. Stream types are extensible, so if you find that what you're building doesn't kind of fit in with the current stream types that we offer, you can always create a stream type and have a custom stream type that works on the Ceramic network. And then all of those things get combined, right? We get the log of commits, and at some point, when a change happens, we make what's called an anchor commit, and we say, all right, let's go ahead and write those updates down to a blockchain. So we're keeping track of the commits on chain, not necessarily the data on chain. So this is really small on chain interactions. And again, the things that are being anchored to the blockchain are encoded using IPLD. So again, on top of IPFS. All of that is great, but it kind of like sets us in this weird realm of all the streams that exist are globally readable, which is kind of cool and also kind of scary at the same time, and something to be aware of. If everything is globally readable, then it's probably not a good idea to store credit card numbers on the Ceramic network, right? It's not encrypted by default. You would need to add some sort of encryption layer to it, like LIP protocol, in order to get everything to be encrypted. It's globally readable, which means I just need to know the name of the data model. And when somebody connects a wallet, if they have data associated with that data model and that decentralized ID that they have, then we can read that in. But applications can't change it. Only the owner of the stream, the controller of the stream, can change it. And we get that control through this authentication mechanism that exists. We typically authenticate one of three ways. Right now, if you're an end user, the most common, or for your end users, the most common way to connect is through something called 3ID Connect. This is a little modal that will use your like MetaMask to create a decentralized identifier, which is then used as the controller for a stream. It's a little clunky. You have to sign a couple messages, so it takes a little bit more time than we'd like it to, but there's a solution for that. The second common way is a key did method, which is you're setting that up more at build time. Developers are probably going to use these as they create and publish the data models for themselves. Or if I had a service that needed to read and write, more so write to the Ceramic network, I might give that service its own key. It's not going to have a wallet to interact with, right? So I would use this type of method. And the most common and preferred way right now that we want you to use going forward is the whole sign in with Xflow. So, right, sign in with Ethereum, sign in with Solana. These authentication flows are becoming more and more prominent, and we have factored them into something called Cacao, which is a chain agnostic capabilities object, which will allow you to use your wallet, sign less messages, you authenticate into the application that way, and then the application gets to act on your behalf for a dedicated session time, right? So you can set that as like 3 hours or whatever, and then that DID that the application is using is ephemeral and it will be destroyed, and you would need to re-authenticate to write changes again. So globally readable, but we have different ways to authenticate so that we can make updates. You cannot make updates to a stream you don't own, so that kind of protects it. So it all kind of looks like this at the end of the day. We have a developer using a DID, probably a key did, to create the definition of a data model. In this case, it's a basic profile, and he's got a schema outlined, and it's just a basic JSON schema. Then we have two users. They've created DIDs, most likely using Cacao or 3ID Connect, in which case they can write data to their own version, like a copy of this object for them. So they can write their individual records, and everybody can read these individual records, but only the controller can make changes. So the entire table of a user's data is now with a user rather than with the application. And every application they go to could potentially read from that. What we get out of this is user agency. Now users own the data. It's not stored in an application-specific database, and I need a DID or to use it as a controller to make any changes to that data. So applications can't change the data unless we're using Cacao and we're giving the application a very specific capability to be able to change that data. So that's the data composability piece. Let's talk about the network side of it. So we're a decentralized network for composable data. We talked about data. Here's the network. Traditional blockchain stuff in a very high level view, right? Blockchains give us this single global execution environment. Think the EVM, right? every transaction that we want to take or that we want to carry out on Ethereum, or every smart contract we want to execute, goes through this EVM. And it's kind of a single point of failure to some degree. There's a limited number of transactions EVM can process at any given time. And the more congested it gets, the more expensive it is to perform one of these actions. And really what it's responsible for is taking the state of like this single global ledger and publishing it out to everything that's participating in its network. So we can kind of think of this as the traditional way. And by understanding that, we can kind of understand what Ceramic's doing. So instead of there being one giant global ledger that needs to be broadcast out to everything or every node that's participating, each of our nodes, like when you run a Ceramic node, it's a really small package that you download. When you run a Ceramic node, each individual node has its own individual execution environment. So there is no global ledger to keep track of. And a node becomes responsible for validating all the commits and transactions that take place on the streams that it cares about. This allows us to scale horizontally. If we need more processing power, we just add a node to the network. So there's less, there's not a single point of execution on this. We can add more points of execution by adding nodes. This gives us the ability to increase the number of processors working on the problem, right? All of this works because it's kind of offline first. So a Ceramic node, it does all of its stream transactions locally to itself, and then it syncs those updates with the rest of the network. And it does that over libp2p. So that's what all the communication between the nodes uses to take place as a pub subtopic that they all kind of subscribe to. This is awesome because if it means for any reason you lose connection to the network, it doesn't mean your application that is connected to your node needs to stop working. It will work, and then when the node comes back online, everybody gets that update available. And this works because everything is done in a global namespace. So even though we might be running a node in AWS and then a node locally in my house or whatever it might be, we can still communicate node to node, and nodes can broadcast stuff out to each other and make sure that everything gets updated. So it kind of looks like this. Each node has some responsibilities and a very key characteristic. The first major responsibility of a node is to like manage the state of a stream, like is to keep track of that. So a node only keeps track of a stream that it cares about. It's called pinning. So if you look in the documentation, you're seeing stuff about pinning a stream. It just means you're telling a node like, I want you to pay attention to this stream. That means if there's 5 nodes, they might not all care about the same streams. So one stream can be, the state can be maintained by all 5 nodes, or 2 of those nodes maybe update or keep the state up to date. So stream states can be maintained by multiple nodes, or multiple nodes can maintain a single stream state as well. So if you needed some sort of like redundancy, you could say, hey, these 3 nodes are going to manage the basic profile stream state. This commit log storage, what they're responsible for is just really maintaining a local copy of all the commits that happen to the streams that they care about. So again, this might be one to many, it might be many to one, but this is the main purpose of that Ceramic node, is to keep track of the stream. We're working on something called persistence connectors, and this will allow you to say, hey, I need to back up that log. Like we have this commit log, it's very critical to the application, and I want to back it up, but I want to do it in a decentralized way. Very soon you'll be able to plug in like Filecoin or Arweave or something in there to do all your backups of your commit logs. The last 2 things that nodes are really responsible for is that query and response, and like broadcasting those transactions. So again, when your client, like when your application says, hey, can I get Matt's basic profile? The Ceramic node goes, oh, let me see if I care about that stream. If I care about it, then I return the stream. And if I don't have it pinned, then I broadcast out that I need that. And some other node on the network will deliver it to me, and then I can show it in my application. And same thing when changes happen. And again, all of that happens over libp2p. The final kind of characteristic to this is nodes can exist on multiple networks, not at the same time, but there's a lot of different networks that you can use when working with Ceramic. The first one is a local network. You can run a node locally in your terminal. It doesn't take a lot of resources to do so. So you can do development locally. We have the testnet, which is called Clay. Clay testnet, you'll be connected to other ceramic nodes. This is the preferred way for you guys to jump in and get started with ceramic. Is just do your dev work on testnet. It'll give you access to the data models that currently exist, as well as make any data models you're working on available to all the other apps in the ecosystem. And we get the composability by doing that. We do have a mainnet. Common misconception is everybody tries to get on mainnet super early. There's a bigger process to getting on mainnet, so I wouldn't struggle with mainnet until you have like a really solid project up and running. So that's kind of like a node and what a node does and is. You can dig into running a node. These can be in the cloud, these can be local, can be wherever you want them to be. Lots of docs on that. So that was a lot, but that covers decentralized data for or network for composable data, right? So all the nodes are the decentralized network. Composable data is what it is. It's a stream, right? So how do we get started? We've provided a couple suites of tools for you. So if you're going through our docs or landing on our GitHub or talking to us in Discord, you might be trying to use something called self ID or maybe Glaze or the ceramic stuff as it stands. And this is kind of the difference between them. If you want your low level interactions with ceramic, like a raw HTTP client, or you want to interact with file document string types directly, then you're going to use the core ceramic package that exists. If you want to abstract that out a little bit and use data models rather than like one-off structures of data, then you're going to need to step up to this package called Glaze. And honestly, this is a really nice wrapper around the low-level stuff. Glaze is probably the easiest one of these to use. It offers a really nice blend between customizability and usability. If you really don't care about how any of it works because you're just writing an app that only needs to consume, then self ID might be the place for you. This is kind of like a package. We got a bunch of like React hooks and everything already pre-built for you. So if you just wanted to plug that into an application and get reading data from the network, you can write with self ID, but if you really wanted to get started and didn't care about the implementation, self ID is your answer for that. So this can kind of get confusing because you might see a blend of these things if you're doing some Google searches to try to figure out how to implement this. So having the understanding that these are three very separate things that all kind of do the same thing with different layers of abstraction will help you along that road. The final thing I can throw at you is we got all these resources here for you. I know it's hard to click a link on a screen. It's hard to do so in a video as well. But if you want to see what's up next for ceramic, this roadmap is super important. It's up to date. We keep it. It's a live living document. So you'll be able to find out everything that we got going on now and in the near future for the protocol. Documentation is always your friend. Then I want to point out that we do have our Discord. We welcome you over there. So come join us. We can answer your questions directly. We do everything in our power to spend a lot of time with the community and help you guys out. For example, I spent some time engineering Cosmos related solutions with a community member over the weekend. It was a lot of fun. So last and certainly not least, before I open it up for questions, is we're hiring. So if you're interested, have data background, have DevOps background, just go look at the job postings that exist. They change frequently, but we're looking for all kinds of talent, both technical and not technical. So even though the market's doing what the market's doing, we are still actively looking for team members. And that kind of wraps it up with about 5 minutes to go. So I will leave it up to you guys for questions for those 5 minutes rather than jumping into some crazy demo.
Awesome, Matthew. Thank you so much for that wonderful overview. Yeah, again, does anybody have any questions for Matt? If not, I have a question. Oh, yeah, yeah. Sorry, go ahead.
Oh, sorry. And my mind kind of wanders, so I may have blanked on this. But you were mentioning that everything is global read, and you have to do your own encryption to make the data private. Is that correct?
Yeah, we definitely don't suggest that you store sensitive stuff on Ceramic. There is no native encryption when it comes to that. However, you can tie in like lit protocols. The best example I have for you on this super easily to encrypt things prior to getting it stored on ceramic if you really needed to. But as things stand right now, like I would highly suggest against storing super sensitive things at the moment.
Awesome. Thanks.
Great question. Anybody else in the crowd have any questions? Okay, I guess I could ask mine. Are there any plans to introduce a GraphQL uh, component to be able to query some of the data on Ceramic?
Yeah, right now that is the biggest change that is taking place. So that's probably the number one thing that's going to stand out on the roadmap. If you do take a look, is we are working really hard to release very soon an entire revamp on how ceramic queries happen to all be GraphQL. So I know I mentioned like data models, and data models are the way we do it today. Data models are changing in a good way. Right now, they're a little bit clunky and hard to work with unless you really understand the differences between build time and runtime with Ceramic.
Mm.
There's a big GraphQL change that's coming that's going to make data models a million times easier to use and to develop and to integrate with, all because it's going to be native GraphQL.
Awesome. Awesome. Can't wait. Can't wait to play with it.
Yeah, me too.
We have about 2, 3 minutes left here, gang. Any final questions for Matt? Going once, going twice. Sold. Well, all right, gang. Again, Matthew, thank you so much for coming on and giving us that awesome overview of Ceramic. I know I'll probably be taking some time over the weekend to go play around with it. It's been on my list for a long time, as I'm sure the rest of the gang here is. And yeah, I just want to wish everybody a happy Friday, happy Saturday, happy weekend, whatever it may be for you. And I'll be posting a link to the attendees POAPs in the developer's voice text. And Matt, I'll forward you your special Dev and Tell speaker POAP as well.
Excellent. Thank you guys for having me, and enjoy your weekend.
All right, gang. All the best. Cheers.